Hello guys, and welcome back to the reaction zone. In today's lesson, we're going to look at the electrolysis of aqueous NaCl using mercury as the cathode. Now, in this process, there will be four types of ions in solution: sodium ion, chloride ion, hydrogen ion, and hydroxide ion. At the mercury cathode, sodium ion is the positive, which means that sodium ions undergo reduction to form sodium atom. Now, this is because sodium has a strong affinity for mercury. So despite the fact that hydrogen is lower than sodium in the electrochemical series, sodium will still be preferentially discharged. So what happens at the mercury cathode is that sodium ions undergo reduction by gaining electrons to form sodium. But that sodium that is formed dissolves in the mercury cathode to form what is called sodium amalgam. And the reason for this is to prevent sodium from immediately reacting with water. Now, at the anode, chloride ions will be deposited in preference to hydroxide ions. So it means that chloride ions will undergo oxidation by losing electrons to form chlorine gas. Now, at the end of this electrolytic process, in a separate cell, the sodium amalgam that is formed at the cathode can react with water, leading to the formation of hydrogen gas and concentrated sodium hydroxide. So, this is what happens in the electrolysis of aqueous NaCl using mercury as the cathode. Mercury is an active cathode. In other words, it is not an inert electrode. And this is why sodium is deposited at the cathode instead of hydrogen, which is lower when compared to sodium in the electrochemical series. I want to believe that this explanation is clear. Thank you very much for viewing, and see you in the next one.